So the next problem is to look for the limit of the given rational function. So that is the same as x raised to 3 minus 9x plus 10 over x raised to 2 minus 4. Okay? As your x is approaching 2. Now notice that when we will be using the direct substitution, which is the same as we substitute your x with 2, that is 2 raised to the second power, which is 4 minus 4, it will give you 0. Now what about the numerator? 2 raised to 3, that is 8, and then that is minus 9 multiplied by 2, that is 18. So 8 minus 18, it will give you negative 10, plus 10, it will give you again 0. So the result of this one would be indeterminate when we will be using the direct substitution. And so how do we compute now? If that is an indeterminate, if the result is indeterminate, meaning to say we find ways on how to get the limit. Okay, we find ways on how to get the limit. Number one, or the next method that we might be using is we reduce this rational function. How? We get the factor of the numerator and of course the factor of the denominator. So if there are common factor, and that's the time we have to cancel out. But the problem in here is how do we get the factors of the numerator, assuming that you do not know the sum and difference of a cube. Okay, the simple method is we divide this one. We divide the numerator to get the factor. What is our divisor? The factor of our denominator. What are the factors of our denominator? So our denominator is x raised to 2 minus 4. The factor is x plus 2 and then x minus 2. Now, notice that when we are going to look for the factor, the divisor, we are going to use this one. Okay, we are going to use this one as our divisor. And so let's try to look for the factors of our numerator by using the simple division or the synthetic division. So in the synthetic division, we get the numerator. So our numerator is x raised to 3 minus 9x plus 10. And what are we going to do with this one? We will divide. What would be our divisor? This one. So our divisor is x minus 2. And so if that is x minus 2, we say now that x raised to 3 divided by x will be x raised to 2. Considering the idea of simple division or division, that is x raised to 2 divided by x, it will give multiplied by x, it will give you x raised to 3, just the same. Multiplied in here, it will give you negative x raised to 2. And so after that one, according to this rule, we have to subtract. So this is 0. What about this one? It will be positive 2x. Okay, so this will change. So we will subtract. I said we will subtract a while ago. So if we will subtract this one, this will change. But because you can never subtract that one with there, because this is raised to the second power, we just copy 2x raised to 2 and bring down 9x. Okay. After that one, we divide again this one by your x. So 2x divided by 2x raised to 2 divided by x. So it will give you positive. Okay. It will give you positive 2x. So that if you will return it back again, multiply, it will give you positive 2x, just the same, raised to 2. What about this one? It will give you negative 4x. So that in the rule of division, you subtract. So this one must be opposite. So that is 0. This one must be opposite. So positive 4x. It will give you negative 5x. Again, bring down 10. So we have in here. So when we bring down 10, we have now negative 5x plus 10 divided by x. So that is to be divided. So it will give you negative 5x. Now return it back. It will give you negative 5x. And then it will give you multiply, that is positive 10. Now after that one, notice that you have to subtract them, and so this will be 0. Okay, subtract them and this will be 0. Now with that now we can therefore conclude that the factor, okay, the factor of our numerator, okay, the factor or factors of our numerator is what we have in here, the quantity x minus 2, and okay, this one, x raised to 2 plus 2x minus 5. So that is the factor. Now what about the factor of our denominator? Definitely we have in here x plus 2 and x minus 2. Okay, with that, notice that they have common factor. The numerator and denominator have a common factor, which is this one, x minus 2 and then x minus 2. And so with that, we have now a new reduced limit. Okay, so what is the reduced limit? That is the same as the limit of what is left. What is left is x raised to 2 plus 2x minus 5. And what about the denominator? x plus 2. As your x is approaching positive 2. And so with that now, we can now use now the direct substitution, or we can now simplify or substitute. So that is the same as replace it in there. That is 2 raised to 2 plus 2 multiplied by x, which is 2. That is the same as minus 5 over, that is the same as 2 plus 2. And so it will give you now a result of what? That is 4. That is 4. 8 minus 5. We have now 3. And that is the same as over 4. And so with that, the limit of the problem is 3 over 4. So we can now say that the limit of the problem x raised to 3 minus 9x plus 10 over x raised to 2 minus 4, as your x is approaching 2, is 3 over 4. So that is the limit. A while ago, it is indeterminate. But because we have to find ways on how to look for the limit, we reduce them. By how? We get the common factor of the numerator, which is this one. We use the synthetic division. And we get the factor of the numerator. Okay? And then after that one, the denominator, as you can see, they have common factor. So that is cancelled out. What is left now is x raised to 2 plus 2x minus 5 over x raised to 2 over x plus 2, I should say. So we have in here now the reduced limit. So we have in here the reduced limit. Okay, now after that one, we are now going to have now the direct substitution. And so by having the direct substitution, it will give you now a result which is the same as 3/4. And so we can now say that the limit of our function 3 raised to x raised to 3 minus 9x plus 10 over x raised to 2 minus 4, as x approaches 2, is 3 over 4. Meaning, as your x is approaching 2, the limit is also approaching 3 over 4. Okay, so that is how to do this problem. I hope you understand. So before we go with the next problem, may I again encourage everyone to please support this channel so that your classmate or some the student like you will also have something to watch when we will be continuing this vlogging of this lesson. Okay, please subscribe and click the notification bell so that every time that we will be having a new posted lesson, you will be notified with that lesson. Okay, so let's try to see the number 2. For the number 2, for the function given by f of x is equal to x raised to 2 minus 1, it says in here, find the limit of f of the quantity 3 plus h minus f of 3 over h as your h is approaching 0. Now notice again that when we will be having a direct substitution in here, that is the same as to substitute the h to 0. Definitely, if this is not undefined, the result will be indeterminate. Okay, the result will be indeterminate. And so how do we solve for this one? How do we look for the limit? Definitely, we have to simplify. We have to simplify our limit. And so let's try to simplify. So having said that one, our limit, rewrite it in here, our limit, that is the same as the limit of f of 3 plus h minus f of 3 over h as your h is approaching 0. Now we have to simplify this one. Okay, now let's try to evaluate. Notice that in our function is defined by x raised to 2 minus 1. The given 3 plus h in here is actually the value of x, so that when we are going to use this one to be the value of x, that is the same as we have to raise it to the second power, definitely minus 1. So when we are going to do that one, simplify, we have now the limit of, we have to enclose with the parenthesis. Okay, we have to enclose with the parenthesis. That is the same as we have 3 plus h, okay, that is the value of our x, that is raised to the second power, minus 1, okay, minus 1. That is actually our first function in here. It says in here minus f of 3, minus, what is the f of 3? Meaning the value of our x in here is 3. So that is the same as when we try to do that one, that is 3 raised to 2. 3 raised to 2. Okay? Minus 1. Okay? So that is how to do the problem. Of course, that is over our h, as your h is approaching 0. Okay? As your h is approaching 0. Now let's try to copy that one. At the same time expand. Okay? At the same time expand. So the limit, okay, expand. Let's try to expand this one. So we have to have the 9 plus 3 multiplied by 2 multiplied by h. So we have 6h, and h raised to the second power, that is plus h raised to the second power. Of course, that is minus 1. Okay? Minus 1. So that is actually our first function. The second function is minus 3. Notice that we have in here 3 raised to 3 is 9. 9 minus 1. Okay? 9 minus 1. And so we have now a result that is the same as h, as your h is approaching 0. Now let's continue it in here. Okay? Let's continue having the operation. We are not yet using the limit. Okay? So let's try to just recopy the limit. Okay? Now this one, subtract. Okay, subtract. That is the same as 9. 8. 9 minus 1, that is 8. Okay, so we have 8 plus 6h plus h raised to 2. What about this one? What about this one? We have in here 9 minus 1, that is 8 multiplied by negative. So it will give you negative 8. Of course, that is over h, as your h is approaching 0. Notice that when we continue, 8 minus 8 is 0. Now, what is left now is the limit of 8 minus 8, 0. What is left now is 6. Okay? 6h plus h raised to 2 over h, as your h is approaching 0. Notice again in here that we reduce the limit, this limit into this form, okay, into this form, so that if you notice, if we have the direct substitution, still the result will be indeterminate. Okay, so the result will be indeterminate. So 0 multiplied by 6, 0 multiplied plus 0, 0. How about the denominator? 0. So with that, we have to still consider again the process. Okay, why? Because the result is indeterminate. Okay, we have to insist of having a limit. Okay, not to insist, but of course, if you notice our limit in here, if you notice our limit, now we can still factor it out or reduce this one. Okay, so we can still reduce by how? That is the same as, again, we're not using this one, the limit. Okay, so notice what is the common factor of the numerator? H. So factor out h. What is left? 6 plus h. Okay, so that if we will return, it will give you the original problem over h, as your h is approaching 0. Notice that when we factor out, this is the same as common. So what is left now? What is left now is the same as the limit of 6 plus h, as your h is approaching 0. Okay, as your h is approaching 0. With this, we can have now the direct substitution, or solve now for the limit. And so the limit would be 6 plus 0 is equal to 6. Okay, that is equal to 6. Now remember that when we are in here, we need to still continue, because so as you can see, as you can observe, this one is still factorable. It is still reducible. And so when we reduce them, notice that the next form of the limit is the limit of the quantity 6 plus h, as your h is approaching 0. So the result is 6. So as your h is approaching 0, the limit is also approaching 6. And so therefore, we therefore conclude now that the limit, this one, or this one I should say, this one, the limit of f of 3 plus h, okay, minus f of 3, as your h is approaching over h, as your h is approaching 0 will be 6. The limit is also approaching 6. Remember that we have a given. What is our given? Given function that is the same as our f of x is actually defined by x raised to 2 minus 1. Okay, so our function is actually x raised to 2 minus 1, and so therefore our final result would be 6. Okay, I hope you understand how to get the limit given this scenario of the problem. Okay, so once again, thank you so much, and again I would like to invite you to please subscribe the channel subscribe the channel, so that at least we will be very much happy to continue this blogging in as a help to you, our student. Thank you.